Okay, let's just continue talking about quadratic graphs, graphs of quadratic functions. Now for each of these graphs, you will see something. You will see that they have a minimum value here, and if we modify this to make it, let's make it x squared, negative x squared, you will see that this has a maximum value. And if we want to move this graph 1 unit to the right, what we can do is say negative open bracket x plus 1 close bracket squared. Well, this is to the left, minus 1. It should be minus 1 to move it to the right. Good. To move it to the right. So we have 3 graphs here. You have y equal x squared plus 1, y equal x squared, negative x squared minus 1. In fact, let me write that down. This is y equals negative x minus 1 squared, not x squared minus 1. This is negative x minus 1 squared. And of course, we have our old y equals x squared up here, right? So this is this graph. This, of course, is this one, and this is this one. Now, we can draw a horizontal line. This is supposed to be straight. I'm trying to make my line straight. And we can fold this curve over this line to make the left and right match together. Alright? We can draw this vertical line through the y equals x squared. It cuts the y equals x squared into 2 halves, so we can fold both sides to match each other. Left and right would match each other. In this case, for the y equals x plus 1 squared, we can draw this line so it cuts the y equal x plus 1 squared into 2 halves, and we can fold the curve onto itself over this line. Now, each of these lines is called an axis of symmetry, right? So they are called axes of symmetry. So this line is an axis of symmetry. Now the general shape of the axis, the general equation of the axis of symmetry is really x equals negative b over 2a. That's the general equation of the axis of symmetry. Now we can check it out here. Let's look at them individually. Alright? The axis of symmetry. Let's do some erasing here. Let's erase all of these markings. Let's erase everything we have. Well, almost everything. We want to erase this graph, delete, and erase this graph, delete, and concentrate on the y equals x squared. We have y equals x squared. It means, if we look at the general form ax squared plus bx plus c, we see that a is 1 in this case, b is 0, c is 0, because y equals x squared is really y equal 1x squared plus 0x plus 0. Alright? Now x is equal to negative b, which is negative 0, over 2a, which is 2 by 1, but this is 0. So the line, the axis of symmetry is x equals 0. Now it's really the y-axis, because on the y-axis here, x is 0, y is 5, is 0.5 is this graph. At this point this is 1, so this is when x is 0, y is 1. So we have, let me use final point, we have 0, 0.5, the coordinates of this point. The coordinates of this point are 0, 1. The coordinates of this point are 0, 1.5. The coordinates of this point, if we extend the line up, are 0, 2. So x is 0 at this point. This is 0, negative 1. This is the line x equals 0. Alright? And it is the axis of symmetry of y equals x squared. Now, looking further at the axis of symmetry, let's make some modifications to this graph and find a new axis of symmetry for a new graph. Suppose we make this graph x squared minus 3. It should be x squared y equal x squared minus 3. Good. And we zoom out. Now again, the axis of symmetry is this line, and it still cuts the graph in two at x equals 0. Let's see why. Y is equal to x squared minus 3 from ax squared plus bx plus c. You can see this is really y equals 1x squared plus 0x plus negative 3. So c is 3. So x is equal to negative b, b is 0, so it's negative 0 over 2 times a, which is 1, which is 0. So the axis of symmetry is still x equals 0. Let's make some more modifications to this graph, and we get a different graph. X equals, or let us make it x minus 3 close bracket squared. We have a new graph now. Let's erase all of this that we have here, and this is our new graph. Let's zoom in a bit. Now we can see that the axis of symmetry is 3. This line at 3, x equals 3, it seems like the axis of symmetry is x equals 3, because it goes down the middle of the shape of the curve. Let's calculate it. X equals negative b over 2a. But this is the graph of y equals, let me make my line thicker, the graph of y equals x minus 3 squared. If we have x minus 3 squared is the same as x minus 3, x minus 3. So we have x squared minus 3x minus 3x plus 3 3 is 9. So we have x squared minus 6x plus 9. When we say x equals negative b over 2a, we have to identify the b and the a. This number that multiplies x squared is 1. So a is 1, b is the number that multiplies x. It says plus bx. minus 6x is the same thing as saying plus negative 6x. So b is negative 6. The c doesn't come into play here, so we don't have to worry about the c being 9. So this is saying negative b, which is negative 6 over 2 by 1. But minus negative 6 is 6. 6 over 2 is 3. So we can see the axis of symmetry works out so that x equals 3. You see that? This is axis of symmetry. Now, let's modify it again to get a new graph and a new axis of symmetry and see if we can calculate it again. Suppose we make this x minus, this is x minus 3 squared plus 1. What would happen here? Plus 1. X minus 3 squared plus 1. Now, this is y equals x minus 3 squared plus 1. Let's look at the axis of symmetry. When we expand this, we saw before that it was x squared minus 6x plus 9, and then we add the plus 1 at the end. X squared minus 6x plus 10 is what we have. But b remains at negative 6. The number that multiplies x is b, and it remains at negative 6. And a remains at 1 because x squared is 1x squared. So a is still 1. So what we have is minus negative 6 over 2 by 1, which is 6 over 2, which is 3. So the axis of symmetry remains at 3. Meaning 3 goes halfway down the line. So the left and the right looks like reflection of each other. So the axis of symmetry is really the mirror line. The mirror line of this curve. Alright? So you can see that. So that's the axis of symmetry, is really the mirror line. When you have the graph of a quadratic function, the axis of symmetry will be a horizontal line, and when you look at the shape of the curve, the axis of symmetry goes halfway down the curve. So it cuts the curve into two halves. So the left and the right would look like reflections of each other. And the equation of the axis of symmetry is x equals negative b over 2a. So you have to remember that. Alright, so that will be it for this video for now. We'll continue this topic in a new video.